In this video, we will discuss how to decompose a rational function px by qx into partial fractions when its denominator qx contains non-factorizable quadratic factors such as ax square plus bx plus c. Here, the quadratic factor ax square plus bx plus c is non factorizable. So the rational function will be of the form px upon ax square plus bx plus c, where this quadratic factor is non-factorizable. Hello friends, you are watching channel Number Collage. This channel features concept videos on mathematics which you would love to watch. In this case, we write the rational function px upon ax square plus bx plus c as px plus c upon ax square plus bx plus c. Solve it further and find the values of b and c to get the partial fractions. Decompose 8x square minus 12 by x into x square plus 2x minus 6 into partial fractions. We observe that the quadratic factor here is non-factorizable. That is, it cannot be further factorized. So in this case, we write a by the first factor x, and above this quadratic factor, we write bx plus c by x square plus 2x minus 6. It will be by cross multiplication a multiplied by x squared plus 2x minus 6 plus x times bx plus c divided by x times x square plus 2x minus 6. Now here the denominator on both sides being same can be cancelled. So we are left with 8x square minus 12 equals a times x square plus 2x minus 6 plus x times bx plus c. We write the left hand side as 8x square plus 0x because there is no x term in here minus 12 equals, now we will open the bracket and write ax squared plus 2ax minus 6a plus bx squared plus cx. We will collect the like terms together in the right hand side. So we will write ax square plus bx square together and write a plus b times x square because x square is the common factor. Next we will write 2ax and cx together, which will be plus 2a plus c times x because x is the common factor. And finally, we will write the constant term minus 6a. We will equate the coefficients of the like terms and get equations. So first, we will equate the coefficients of x square on both the sides and get the first equation, which will be this a plus b equals 8. So that is our first equation. Next, we will equate the coefficients of the x term on both the sides. So we will write 2a plus c equals this 0. Next, we will equate the constant terms, which are minus 6a here and minus 12. So we write minus 6a equals minus 12, which gives us a equals 2. So this is the value of a that we got here. So we write this value of a here, a equals 2. Now we will substitute a equals 2 here and get 4 plus c equals 0, which gives us c equals minus 4, which we write here c equals minus 4. And finally, we will write the value of a, which is 2, in here and get the value of b. So we write 2 plus b equals 8. That gives us b equals 6. So the third value b equals 6 we write here. Now we will use the value of a, b and c to write the partial fractions as 2 by x plus 6x minus 4 by x squared plus 2x minus 6, where this a is 2, this b is 6 and this c is this. So this is how we decompose this rational function into partial fractions. We will split the rational function x by x square plus 1 multiplied by x square plus into partial fractions, where the denominator of this rational function contains non-factorizable quadratic factors. Therefore, we write this rational function as ax plus b by the first quadratic factor x square plus 1 plus cx plus d by the second quadratic factor, which is x square plus 2. So this by regular method and cross multiplication gives us x equals ax plus b multiplied by x squared plus 2 plus cx plus d multiplied by x squared plus 1. Now we will expand the brackets on the right hand side and write a x cube plus 2ax plus bx squared plus 2b plus cx cube plus cx plus dx squared plus d. Next, we will write the left hand side x as 0 x cube because there is no cubic term plus 0 x square because there is no square term plus this x plus 0 because there is no constant term on the left hand side. Now we will write together the like terms. So first we write the cubic terms together. So we write a plus c times x cube. Next we write the square terms together, that is b plus d x squared. Next we write the x terms together, which will be 2a plus c into x, and finally the constant term 2b plus d. By equating the coefficients of the like terms, we will get different equations. So first we will equate the coefficients of the cubic term and write this a plus c equals 0. So the first equation is a plus c equals 0. Next, we will equate the square terms on both sides. So we write b plus d equals 0. So b plus d equals 0. So this is our second equation. Next, we will equate the coefficients of the x terms. So we will write 2a plus c equals 1. And finally, we will equate the constant term to 0. So that gives us 2b plus d equals 0. Now we have to solve these four equations to get the values of a, b, c and d. So first we will pick up a plus c equals 0 and 2a plus c equals 1. A plus c equals 0 and 2a plus c equals 1. Subtracting, we get minus a equals minus 1. That gives us a equals 1. So here we got a equals 1. Next, we will substitute the value of a in this equation and solve. So we write 1 plus c equals 0. So that gives us c equals minus 1. So we write the value of c equals minus 1 here. Now the equations b plus d equals 0 and 2b plus d equals 0 gives us both b and d equals 0. So we write b equals 0 and d equals 0. So the partial fractions of this rational function will be x by x square plus 1 minus x by x square plus 2. Let us resolve x square minus 3x minus 7 by x square plus x plus 2 multiplied by 2x minus 1 into partial fractions. Here in the denominator there is a non-factorizable quadratic factor, so we write a by this linear factor 2x minus 1, and above the quadratic factor we write bx plus c by x square plus x plus 2. Now by usual method we will cross multiply and cancel the factors in the denominator and write x square minus 3x minus 7 equals a times x square plus x plus 2 plus px plus c multiplied by 2x minus 1. We will expand the brackets and write ax square plus ax plus 2a plus 2b x square minus bx plus 2cx minus c. Next we will write the like terms together. First, the square terms a plus 2b into x square. Next, the x terms 2c minus b into x. And finally, plus the x terms a minus b plus 2c into x. And finally, the constant terms 2a minus c. Now we will equate the coefficients of the like terms on both the sides and write the equations. The first we will equate the coefficients of x square and write a plus 2b equals 1. Next we will equate the coefficients of x on both sides and write a minus b plus 2c equals minus 3. And finally we will write the constant term, that is 2a minus c equals minus 7. We have to solve these three equations to get the values of a, b and c. First, we will take up this equation which gives us 2b equals 1 minus a, b equals 1 minus a by 2. We will substitute this value of b in the second equation and write a minus 1 minus a by 2 plus 2c equals minus 3. Multiplying throughout by 2, we get 2a minus 1 plus a plus 4c equals minus 6. So that will be 3a plus 4c equals minus 5. We name this equation 1. We will multiply the third equation by 4 and write 8a minus 4c equals minus 28. We name this equation 2. We will add these two equations. 4c minus 4c will be 0. So this will be 11a equals minus 33. That gives us a equals minus 3. So this is the first value that we got. We will use this value of a here and find b equals 1 plus 3 by 2, which will be 2. So the second value is b equals 2. To get the value of c, we will substitute a equals minus 3 in the third equation here and write 2 multiplied by minus 3 minus c equals minus 7. So that gives us c equals minus 6 plus 7, that is 1. So c equals 1 is the third value that we got. So we have a equals minus 3, b equals 2 and c equals 1. Now we will write the partial fractions as first we will write the positive terms. So we write the second term first. So it will be 2x plus 1 by x square plus x plus 2 minus 3 by 2x minus 1. So these are the partial fractions of this rational function. Let us understand how to decompose an improper fraction into partial fractions. A function px by qx is called improper fraction or function when the degree of px in the numerator is greater than the degree of qx in the denominator. In that case, we have to long divide polynomial px by qx so as to get the quotient rx and the remainder sx and the remainder sx, so that we write the rational function px by qx equals rx plus sx by qx, where sx by qx is a proper function which can be decomposed into partial fractions by usual methods. Resolve x cube by x square minus 1 into partial fractions. Here the degree of x cube is 3 and that of x square minus 1 is 2. Since degree in the numerator is greater than the degree in the denominator, this rational function is improper fraction. In order to resolve this improper fraction into partial fractions, we have to do the long division process. For that, we will divide this x cube by x square minus 1. So we write, first we will divide this x cube by x square to get x, which we write here. After that, we will multiply this x square by this x to get x cube. Then minus 1 into x will be minus x. We will change the signs, so this gets cancelled and we get x. So this x is our quotient q and this x is remainder r. Therefore, we can write this improper fraction as x plus remainder x upon the divisor x square minus 1. This is a proper fraction which we can easily resolve into partial fractions by usual methods. Now we write x by x square minus 1 as x upon x square minus 1 can be factorized as x plus 1 multiplied by x minus 1. So we write this as a by x plus 1 plus b by x minus 1. This becomes x equals a times x minus 1 plus b times x plus 1. We will substitute x plus 1 equals 0. That gives us x equals minus 1. So we will substitute x equals minus 1 in this equation and write minus 1 equals a multiplied by minus 1 plus b multiplied by 0. That gives us minus 2a equals minus 1, that is a equals 1 by 2. We got a equals 1 by 2. To find the value of b, we will substitute x minus 1 equals 0. That gives us x equals 1. So we will substitute x equals 1 in this equation and write 1 equals a multiplied by 0 because x minus 1 equals 0 plus b multiplied by 1 plus 1. So that gives us 2b equals 1, that is b equals 1 half. The value of b is 1 half. The partial fractions become half by x plus 1 plus half by x minus 1. Therefore, the partial fractions of this improper function will be x plus half by x plus 1 plus half by x minus 1, that is x plus half times 1 by x plus 1 plus 1 by x minus 1. So these are the partial fractions of the improper function or improper fraction. Decompose into partial fractions 4x cubed plus 10x plus 4 upon x times 2x plus 1. We write this as 4x cube plus 10x plus 4 upon 2x square plus x. Here the degree of the numerator is 3 and that of the denominator is 2. Since 3 is greater than 2, this is an improper fraction. So, in order to find its partial fractions, we have to carry out long division process. So, we will divide 4x cube plus 10x plus 4 by 2x square plus x. First, we will divide this 4x cube by 2x square. 4x cube by 2x square, that gives us 2x. We write this 2x over here and multiply this divisor 2x square plus x by 2x and write over here. That gives us 4x cube plus 2x square. We change the signs so this gets cancelled. We write 2x square plus this 10x plus 4. Next, we will divide this minus 2x square by 2x square minus 2x square divided by 2x square gives us minus 1. So we write this minus 1 over here. Then we will multiply 2x square plus x by minus 1 and write minus 2x square minus x plus 4. Let's change the signs. Plus plus, so this gets cancelled. This will be 11x plus 4. So this is our quotient and this is remainder. So we write quotient equals 2x minus 1 and remainder 11x plus 4. So we write this improper rational function as 2x minus 1, which is the quotient, plus 11x plus 4, which is the remainder, divided by the divisor, which is x into 2x plus 1. Now this is a proper function which can be resolved into partial fractions by usual method. So we write this proper function 11x plus 4 by x into 2x plus 1 equals a by x plus b by 2x plus 1, because the denominator contains non-repeating linear factors which can be written as 11x plus 4 equals, by cross multiplication, a times 2x plus 1 plus b times x, which will be 2ax plus a plus bx, that is 2a plus b times x plus the constant term a. Equating the coefficients of the like terms, that is equating the coefficient of the x term, we write 2a plus b equals 11 and this a equals the constant term 4. We will substitute value of a here and write 2 times 4 plus b equals 11. So b will be 11 minus 8, that is 3. So we have a equals 4 and b equals 3. We write the partial fractions as 4 by x plus 3 by 2x plus 1. So these are the partial fractions of this proper function. The partial fractions of this improper fraction will be 2x minus 1, which is this, plus 4 by x, which is this, plus 3 by 2x plus 1. These are the partial fractions of the given improper function. Friends, if you like this video, please click the like button. Share this video with your friends and classmates. Do subscribe this channel to get more videos of this type. See you in the next video. Until then, keep watching Number Collage. Thank you.